General Physics 1, Quarter 1, Module 5, Lesson 3, Work. What is work? Work is a dot product of force and displacement. It is a scalar quantity, no direction is associated with it. In addition, work is also related to energy. Energy is transferred if we do something on an object. Work exists if a force made a body where it acted on moved at a distance. The system unit for work is joule or Newton meter. The formula for work is work equals the product of force and distance. Pushing and pulling objects, making them move at a distance, is an example of situations where work is done. Problem 1. Nico exerted 20 Newton on a table, making it move through a distance of 2 meters. How much work was done by Nico on the table? The given force is 20 Newton. 20 Newton. The distance is 2 meters. And how much work was done by Nico on the table? Work is unknown. We need to find the work. Solution for this, we need to use the formula work is equal to force times distance. Work is equal to the product of force and distance. The substitute force, the force is 20 Newton, while the distance is 2 meters. 20 Newton times 2 meters is 40 Newton meter, or 40 joules. So our conclusion will be 40 joules work was done by Nico on the table. 40 joules. So Nico done at 40 joule work on a table to make it move through a distance of 2 meters. If height is involved in the system, work has this formula. Work is equal to mgh. M stands for mass of the object in kilograms, while g is the acceleration due to gravity, which is 9.8 meter per second square, while h is the height in meters. So let's proceed to problem 2. I lifted my 0.4 kilogram smartphone to a 1.2 meter high chora box. What is the work done? So the given mass is 0.4 kilogram and the constant acceleration due to gravity is 9.8 meter per second squared. But wait, because the work done here is against the gravity, so with the acceleration due to gravity will be negative 9.8 meter per second squared. So the given height is 1.2 meter high, 1.2 meters, and the work is what we are going to find. Work is unknown. So the solution will be like this. Work, we need to use the formula work is equal to the product of mass times acceleration due to gravity times height. So let's substitute the values. Mass 0.4 kilogram times negative 9.8 meter per second squared times 1.2 meters. So the answer will be negative 4.7 joules. Negative 4.7 joules. So the Therefore, the work done is negative 4.7 joules. The work done on the smartphone is negative 4.7 joules. Meanwhile, if force and displacement are not parallel to each other, only the component of the force that is parallel to the displacement does the work. If F and D are not parallel to each other, only the F component that is parallel to D does the work. I have learned that the magnitude of the component of F parallel to D, given the angle in between the directions of force and displacement, is F cosine theta. Force cosine theta. Force cosine theta is the magnitude of the component of F parallel to D. We can say that force is acting in a direction that is opposite to the motion of the object if the calculated work or the work we got after solving the problem is negative. This case is written in equation as work is equal to the product of force and distance times cosine theta. Work equals force times distance times cosine theta. So let's have another problem. Grisha, whose weight is 441 Newton, walks up the stairs where the vertical distance between the floors is 3.5 meters. Calculate for the work done by gravity. So our given here is R, force, distance, and cosine theta. The given force is 441 Newton, while the given distance is 3.5 meters. The cosine theta we're going to use is cosine 180 degrees. It is because Grisha's direction as she walks up the stairs is directly opposite to the direction of gravity. So it will be cosine 180 degrees. Solution. We need to use the formula work is equal to force times distance times cosine theta. Let's remove this. Okay, it will be like this. So let's substitute. Force 441 Newton times distance 3.5 meters. Then cosine 180 degrees. So work will be 441 Newton times 3.5 meters times cosine 180 degrees is negative 1543.5 joules. So therefore the work done by gravity is negative 1543.5 joules. The work done by gravity against Grisha is negative 1543.5 joules. It is negative because their direction is opposite to each other. The work done, the direction of the work done is opposite to the work done by gravity. The work done by Grisha is opposite to the direction of gravity. On the other hand, if the force exerted is at the right angle to the displacement, no work is done. Right angle is equal to 90 degrees. And cosine 90 degree is equal to 0. If we're going to compute it in a calculator, cosine 90 degrees will be 0. So no work is done. No work is done. So let's move on to problem 4. If a book weighing 9.8 Newton is attracted to the end of the rope and dragged across a horizontal floor, how much work is done if the rope makes a horizontal angle of 90 degrees and the book is dragged over a distance of 10 meters? So our given is, the given force is 9.8 Newton. And the given distance is 10 meters. We're going to use the cosine 90 degrees because the horizontal angle the rope made is 90 degrees. So we're going to compute for work. Work is unknown. So the solution, work is so like this. Work, substitute 9.8 times 10 meters and cosine 90 degrees. So the answer will be 0. So the conclusion, no work is done. I just made it to show you that if we have cosine 90 degree, work will result to 0. Automatically, no work is done. That's all for this lesson. Thank you.